can program a finished return, we're going to need some important information about the tools that we'll be using. Sometimes there's multiple diameters in a profile set. We will want to choose the largest one. This eased edge set that I'll be using for this example consists of both 80mm and 77mm tools. These measurements can come from an accurate drawing or physically measuring the tools with a caliper. The measurement that is the most important to us is the smallest diameter of the tool. So the tool on the right is the largest, so that's the one we'll work with. We'll also need the largest diameter that actually touches the stone. Sometimes we call this the ride height. If you have an accurate tool drawing with your ride height defined by the small circle, you can use this as the measurement by mirroring it over to the other side. The distance between these 2 points is the second diameter that we'll need. We can also get these 2 diameters off of the tool itself. We can measure the small diameter of the tool, and then if the tool has been ran, we can measure from the outermost wear mark on the one side to the outermost wear mark on the other side. We'll use these 2 diameters to draw circles in AlphaCam. So I'll choose to draw a circle, center plus diameter. One of the diameters was 2.957, and I'll make the center of it be at 0, 0. Then I'll draw the second circle, center and diameter, with a diameter of 2.56, and I'll have the center of it be at 0, 0 as well. It's important that both circles have the same center point. Next, we'll draw a line. We'll start the line at the 9 o'clock quadrant of the smaller circle, and we'll turn on our ortho to bring it straight up and past the second circle. And then we'll trim the line against the larger circle. The length of this line is the distance that we need the center of the tool to stop early to avoid the edge of the tool going past. We'll save this number for this profile set. And I'll use this profile set on a windowsill for this example. This windowsill would be going through a wall, and I would want my edge profile to stop before it reached the wall. So I'll draw a line at this location so I know where I want my edge profile to stop. Then I'll offset this line by my stop distance for this profile set, which was 0.74. I want to offset in this direction to shorten my cuts. I'll be using this line to break my cut profile line on both sides. When I choose break, I'll set it to geometries and using a cutting geometry. I'll select the offset line, finish, and then I'll select the profile line to be cut and finish. I'm going to turn off all my video reference objects, and then I'm going to delete the line that represented the wall. And I won't even need my offset line because I already used it to make breaks in my cut line. Next, I'm going to draw arcs at each end of my profile cut line to control the lead in and the lead out. I'll make a circle to get my arcs. The circle that I draw will have to have a slightly larger diameter than the small diameter that I measured on my tool, which was 2.56. I'll make it slightly larger by adding 10 thousandths plus 0.01. And then I'll just place this circle somewhere in my drawing. Then I'll draw a horizontal and vertical line using the quadrant snap, which is my F5 key. And I'll use these lines as cutting geometries to put 4 breaks in my circle. And then when I delete my cutting geometry lines, I'm left with 4 arcs. Next, I'll move and select the appropriate arc by the correct endpoint and place it at the end of my profile line so that it will lead the tool away from my part. And I'll repeat the process for the other end of my line as well. We'll also need a straight line to guide the tool directly away from our part. I'm going to do this by drawing a line starting at the endpoint and turning on my ortho, the F3 key, to drag the line away from my part. And I'll repeat this on the other end as well. These segments are what I'll want the tool to follow, so I'll join them all together as one. This method works great if your parts are straight and square. If your part isn't straight, then this method with the lead in and outs could cause one end to dive into the material and the other end to lead out too early. So here's a second way to draw your leads. I'm going to delete all the extra geometry just to make it a little easier to see. We're going to have to first extend the ends of the lines by the radius of the cutter that we're using. I'll use extend by distance to do this. The small diameter of the cutter that we're using was 2.56, and I need the radius, so I'll just divide that by 2 and choose both ends of the line to extend. Next, I'll draw a line that starts at the end of and is perpendicular to the existing line. The length of this line will have to be longer than the radius of the tool, which we'll have to eyeball, but we'll be able to verify after the next step, which is fillet. And this radius will have to be slightly larger than the tool. The tool's diameter was 2.56, which we would make slightly larger, maybe 2.57. And then, since we want the radius, we'll divide it by 2. And as I apply each fillet, I can see at the ends I have a flat straight line, which tells me that the length of my line is longer than the radius of the cutter. And no matter which method you use to create your shape, we can apply tool direction like we normally do, and also the style using that tool. And here we can see our sharp lead in and our sharp lead out, which we'll also see in simulation. Thank you for choosing Park Industries.